Hello, everyone. We are back talking about Chapter 2, Integers and Rational Numbers, Lesson 7, Comparing and Ordering Rational Numbers. Now, there's this word rational numbers, and so it's important to know what that word means. To understand what that word means, we really need to understand what all the numbers and the names for the numbers are. So I don't have a lot of space, but I'm going to kind of do it right here in the corner. Okay, so the first type of numbers there are the natural numbers. And the natural numbers, those are just numbers that you normally count with. So 1, 2, 3, 4, 5. Those are all natural numbers. Okay, those are called natural numbers. Now, after natural numbers, there are whole numbers. Whole numbers include all of the natural numbers. So 1, 2, 3, 4, that is a whole number, but the extra number that whole numbers have is 0. So whole numbers, and I'm drawing a circle around everything just to show that whole numbers include all of the natural numbers and 0. Okay? So those are whole numbers. So natural numbers, the ones we naturally count with. Whole numbers are the include 0. After whole numbers, there's integers, and we've talked about integers. Integers, if you remember, are positive whole numbers, so 0, 1, 2, 3, 4, 5, 6, and so on, and also negative. So -5, -4, -3, -2, -1, 0, 1, 2, 3, and dot, 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 which means it keeps going on and on. So those are integers. Then what we get to are the rational numbers. And that's what we're talking about here, rational numbers. Okay? Now, the rational numbers those are two characteristics. There's fractions that can be a terminating decimal. I'm running out of room. Decimal, like what we talked about last time. Or the second type of rational number is a fraction that can turn into a repeating decimal. So, some examples of rational numbers. 3/4 is the same thing as 0.75. So that is a terminating decimal. And also 1/3 can be written as 0.3, and the 3 is repeating. So that's a repeating decimal. So those are all rational numbers. Or you could have, -2/3, which would be -0.6 repeating, and that kind of carried over in there. But rational numbers are also integers. They're also whole numbers, and they're also natural numbers. So I'm going to draw a circle around everything because those are what rational numbers are. So whenever you see the word rational numbers, so we're talking about integers, that's positive and negative whole numbers, and we're talking about rational numbers, which are fractions that can be turn into terminating decimals, and they're also fractions that can be written as repeating decimals. So those words really they mean a lot. Integers and rationals, those may be new words for you, but they have a meaning. So it's very, very important that you understand the meaning of the words that you're working with. So that's what this whole chapter is about, integers and rational numbers. Lesson 7 is about comparing and ordering rational numbers. And the numbers that it's talking about is anything within this pink circle. So natural numbers, whole numbers, integers, any of those rational numbers, we're going to compare and we're going to order them from least to greatest and learn about them. So to start off, let's talk about comparing decimals. So to compare decimals, one way to do it is to add zeros so that each decimal has the same number of decimal places. Ignore the decimal points and compare the numbers as if they were integers. So that's just a kind of like a little, kind of cheat roll they use. So if we look here at 4.3 and 4.27, if you see here, this has one decimal place, and 4.27 has two decimal places. So one decimal place, two decimal places. So what this is saying is it's saying, hey, you can just add a 0 right here, and then you make it now two decimal places. So this is 30 and this is 27. And what it's saying is, hey, just ignore, now that we have the same decimal places, ignore the decimals altogether and call this 430 and then call this 427, and which number is bigger? Well, it's obvious that 430 is bigger, so we would make our sign like this. Remember, I always like to call this an alligator, and the alligator eats the biggest number. So we'd say 430 is greater than 427. So that's one way to do it. How I do it is I look at the number in the tenths place. So this goes to the tenths place, and this goes to right there. Those are the tenths place. And this is 3/10, and this is 2/10, and so you would know that 3 is bigger than 2, so you'd know that that one's bigger. So I do it a slightly different way, but this is how one of the ways the textbook is saying that you could do it. So let's look at this next one. We're going to compare the decimals using less than and greater than signs. Okay. So we have 7.2 and we have 7.8. So they both have one decimal place, so that's good. So one thing the textbook talks about is, hey, just ignore the decimals. We got 72 and we got 78. Which one's bigger? And it's clear that 78 is bigger, so the alligator would eat the bigger one. So we'd say 7.2 is less than 7.8. Now, if I was doing this, I don't do it that way, and there's multiple ways to do it, and that's okay. So this would be in the tenths place. This is in the tenths place. They have the same number in the ones, so you would look to the tenths place. There's a 2 and there's an 8, and 8/10 is bigger than 2/10, so that's why the alligator would eat this one. All right, cool. So throughout these, I'm just going to talk about both ways, just so it gives you a variety of options. So, yeah, okay, moving on to the next one. So here we have 2 decimal places, and right here we have 1, 2, 3 decimal places. So one thing the textbook talks about is just, hey, add a 0 so they have the same number of decimal places. Now this has 1, 2, 3, and this has 1, 2, 3. Then you just ignore the decimals and write it. And which number is bigger? Well, 640 is bigger than 604, so that means the alligator would eat the bigger number. So there you go. 0.64 is greater than 0.604. Now, if I was doing this problem, I would look at it like this. Okay, the zeros are the same, the 6s are the same. The thing that is different is not the tenths, the hundredths. So we have a 4 here, and we have a 0 there in the hundredths place. 4 hundredths is bigger than 0 hundredths. So that is why this one is bigger. So that's the way I personally would do the problem. Okay, let's move on to 3. Okay, so we have 2.09 and 2.817. So they both have a 2 in common. Oh, wait, we're doing the decimal places thing first. Okay, so this one they have a 2 in common, so we're looking at the decimal places. So this has 2 decimal places, and this one has 1, 2, 3. So the textbook talks about just adding a 0 so that they have the same amount. And then you just ignore the decimal sign. So we got 2,090 and 2,817. Well, it's obvious this one is bigger. So that means the alligator would eat the bigger number. Okay? If I was doing this problem, 2.09, I'm going to start at the beginning, 2.817. I see that they have a 2 in common, but here in the tens place, that's where they have something different. So I'm just going to compare the numbers in the tens place. 0 tenths or 8 tenths? 8 tenths is bigger, so that means the alligator eats the bigger one. So, yeah, that's how I do those. All right. Let's move on to the next concept in this lesson. So we were talking about decimals. Now we're going to be looking at fractions. So we're going to compare 2 fractions that have different denominators. And just like we did the decimals 2 different ways, we're going to do this one 2 different ways too. So whenever you have 2/3 and 1/2, it's very difficult if you haven't been doing this for a long time to know. So what we have to do is when they have different denominators, we have to get the same denominator. The way you get the same denominator is by something that's called the LCM. Do you guys remember what the LCM stands for? That stands for the L is for least, C is for common, M is for multiple. So least common multiple. Multiples, remember, if you start with a number and you just count by that number. So if we had 3, the multiples of 3 would be 3, 6, 9, 12, 15, 18, and you could just keep going forever. And the multiples of 2 would be 2, 4, 6, 8, 10, 12. Okay? So those are what multiples are. So we need to find the least common multiple of 3 and 2. So multiples are there. Common ones are basically ones they have in common. So if we look here, I see they have a 6 in common. I also see they have a 12 in common, and if I kept going, they would have more in common. But so that's what common multiples are, but we want the least common, which would be 6. 6 would be the least common. So then what we need to do is with 2/3 and 1/2, we need to make it so they both have a 6 in the denominator. So remember, the denominator is the number in the bottom of the fraction. The numerator is the number in top of the fraction. So how do we make this 3 into a 6? Well, one way we can do it is if we multiply the bottom and we multiply the top by 2. What happens is we get 2 times 2, which is 4 on the top or in the numerator, and 3 times 2, which is 6. So now we have 6 in our denominator, which is what we need. But we need to make this 2 into a 6. Well, how do we make a 2 into 6? Well, we can multiply it by 3. If we multiply the bottom, we have to multiply the top. And we can do that because if we look at this, we can multiply by 3 over 3 because what is 3 divided by 3? 3 divided by 3 is actually equivalent, it's equal to 1. And if you go 1/2 times 1, you get 1/2. You get the same thing that you started with. And so 1 looks a little different. We're calling 1 3 divided by 3. And we can do that because it's equal to 1. But what's going to happen when we go 1/2 times 3 over 3 or 1, we're going to get the same thing. We're going to get 1/2. It's just going to look a little different. And so when we do this multiplication, we get 1 times 3, which is 3. And we get 2 times 3, which is 6. And 3/6, it looks different than 1/2, but it's actually the same thing. But now it's easy to compare because we have a common denominator. So they're both 6, so that's great. So then we just look at the numbers on top or in the numerator. We got 4 and 3. Which one's bigger? 4 is. So that means the alligator would eat the biggest one. Okay, so that's how you would do it one way. And that's really the way that you're going to have to do it. But I want to show you guys visually what's going on here. Because sometimes it's just good to be able to understand the concept visually. So here I got these little yellow pink strips. They're not yellow, they're pink. Okay. And what I'm going to do is I'm going to call this one 2/3. And this one is going to be 1/2. So basically, this number on the bottom, that tells you how many things you need to divide this pink strip into. So I'm going to divide it into thirds. So roughly about here and here. Okay, that looks kind of about right. Okay, and then this one I'm going to put into halves. So I'm going to try to line it up directly down the half. Okay, so this is in thirds, this is in halves. That's great. Now what it states is that 2/3. So 2/3 is 2 out of these 3 sections. So if I color that in here, that's how much we have right here. 2/3 would be that much. Just ignore my wonderful coloring job there. Okay, so that would be 2/3. This is 1/3, 2/3. And then right here, 1/2 is just going to be 1 out of the halves. And so there you go. And so you can see visually, these pink slips are both the same size. That 2/3 is more of the pink slip than 1/2 is. So that's just another example how 2/3 is greater than 1/2. Okay? All right, cool. Let's go on to the next one right here. 2/5 and 3/4. So the first way we're going to do it is kind of just mathematically using numbers, and we have to find the LCM, remember, the least common multiple. So we're going to go ahead and count by 5s first. We got to get the same number in the denominator. So we're going to count by 5s. 5, 10, 15, 20, 25, 30. Okay. And then we're going to count by 4s. 4, 8, 12, 16, 20, 24. Okay, cool. So we've done that. Now we need to find a common multiple between the two. And what I see is 20 is a common multiple. If we kept going, we would find more, but this is actually the least common multiple. So what that tells us is that we need to make the 5 and the 4 turn into 20. That's what we need that number to be on the bottom of the fraction. So I have 2/5 here. And how do I make this? And then I have 3/4 over here. You know, I need to make this into a 20. So I need to multiply this by 4, and then I need to multiply this by 4, the top and the bottom. And we end up getting 2 times 4 is 8, 5 times 4 is 20. And then we need to do the same thing here. We need to turn this 4 into a 20. So if we can turn it by 20 by multiplying it by 5, 4 times 5 is 20, and whatever we do to the bottom, we have to do to the top. So we end up with 3 times 5, which is 15, 4 times 5, which is 20. So here we have our fractions, 8/20 and 15/20. So now that they have the same denominator, it's very easy to compare. Is 8 bigger or is 15 bigger? And I think it's obvious that 15 is bigger, so we would say 8/20 is less than 15/20. So that's great. Now what we're going to do is we're going to look at it visually. So I got my little pink slips again here. Try to line them up so they're even. And we're going to call this one on top 2/5. And this one is going to be 3/4. I'm going to go ahead and divide this into fourths easier because fourths is easier than fifths. So I want to get it right down the middle first. And then that's in halves. And then I'm going to split each of the halves into half, which would then give me fourths. Okay? Now I need to do the fifths. Okay, the fifths are slightly harder. I think I'm just going to give a stab at it. So that's going to be 1, 2, 3, 4, 5. Okay, so that's 1, 2, 3, 4, 5. And this is 1, 2, 3, 4. So this is in fourths, and this is in fifths. So we have 2 out of the fifths, so 2/5, so it would be right here. Right there, that would be 2/5. And 3/4 would be 3 out of these 4. And if you can see, 3/4 is significantly bigger. And it's nice to look at this visually because it's way bigger than 2/5. So that is why 3/4 is bigger. So we would say our answer would be 2/5 is less than 3/4. Okay, and that would be our answer. All right, great. So let's go on to 4, 5, 6, 7, and 8. So I would like you to go ahead and pause. I want you to try to do it both ways how we did it up here. Finding the LCM, getting a common denominator. Make sure you write your end answer with the original numbers that they gave you. So when they start here, your answer needs to have those same numbers, okay? And we did the same thing here. We started here, they asked us about this, and our answer is here. Even though we changed the denominator and things like that, which is wonderful, and that's what we need to do, they're asking us to compare 2/5 and 3/4, not 8/20 and 15/20. Even though they're the same thing, we need to answer this question, which is what we did right there. So make sure that when you do these problems, 4, 5, 6, and 7, that you do that. So I want you to do it both ways, where you find the LCM, and then I want you to draw pictures visually so you can do it that way as well. All right, so we are going to go ahead and pause and go ahead and work these out, and I will see you in a little bit. Okay, bye-bye. No, not bye-bye. Just I'll see you in a little bit. Okay, pause. Work them out. Do them both ways.